Modern architecture is changing. Large glass surfaces now define many buildings and interiors. They create transparency, bring daylight into the space, and produce an open, modern appearance. Especially in facade construction, design, function, and technical implementation must work closely together. With large glass surfaces, an important question arises. How can solar radiation be controlled without limiting the design? One proven solution is louvres. They direct light, create shade, and can also be used as a design element. This means they are not only a technical component, but also help shape the character of a facade. At first glance, louver systems may seem simple. In planning, however, they are demanding. Spacings must be exact, profiles must be positioned correctly, and repetitions must be built up cleanly. Especially with larger facade areas, many identical or similar elements must be planned and evaluated precisely. As soon as something changes, additional work is created. Elements must be adjusted, drawings checked, and errors avoided. When changes are updated manually, the risk increases that views, sections, or bills of materials no longer match completely. That is why a control process is needed. This effort costs time, reduces productivity, and can increase costs. At the same time, all relevant information for production must be prepared reliably. Lengths, quantities, material requirements, and further data for ordering and production preparation. The key question is therefore, can this process be made simpler, faster, and safer? This is exactly where ATHENA comes in. ATHENA was developed specifically for metal construction and facade engineering and supports the workflow from planning through to production preparation. The advantage is that users do not simply draw basic lines. ATHENA works with intelligent objects that combine geometry, data, and functions. These intelligent objects form the basis for a structured way of working. They can be displayed, evaluated, and adjusted. This creates parametric views that can be modified in a targeted way. Components can be extended, shortened, or changed without rebuilding the entire structure every time. This is especially useful for louver systems. When several elements are built in a similar way or repeat regularly, adjustments can be made in a much more controlled manner. Even when the geometry changes, the process remains traceable. One object can be replaced by another, including the associated sections and views. This reduces manual rework and avoids unnecessary duplicates. Especially with many identical or similar elements, this saves time in daily work. Planning also remains clearer because objects, views, and evaluations are more closely connected. Another advantage? Planning does not remain purely graphical. Information for evaluation, ordering, and production preparation can be generated from the 2D+ objects. The drawn elements are therefore not only used for representation, but also become a databasis for further process steps. An important point is this: these elements are not rigid blocks. They are intelligent 2D+ objects that can be created flexibly and adjusted easily. Profiles, spacings, and geometries can be changed without rebuilding the construction every time. This keeps planning flexible and controlled. Even before the evaluation, a clear connection is created between geometry and information. What is built up in the drawing can later be reused in a targeted way. Existing objects can be used directly to generate structured results. From this point on, cut optimization becomes the focus. The profiles created in ATHENA can be evaluated specifically and prepared for cutting. This is not only about capturing individual profile lengths, but about bringing existing components together in a structured way. Especially for louvers with recurring lengths, Clear-cut optimization helps use material more efficiently and reduce the effort required in work preparation. The results can be output separately. This creates an overview of which profiles are required, which lengths occur, and how identical elements can be grouped together. After this preparation, the next step is the bill of materials. The evaluated information can be displayed as individual parts or as a summary of identical elements. This makes quantities, lengths, and components easier to check and structure for further processing. The next step is the evaluation in ATHENA. Information from the 2D+ objects is made usable for documentation, checking, and production preparation. This creates a clean basis for summarizing recurring elements and passing on the planning in a traceable way. Automatic dimensioning is especially important here. In ATHENA, relevant profiles can be selected and assigned a reference point. This creates a layout with automatic dimensioning. The required dimensions do not have to be built up manually, but can be derived directly from the existing objects. From this step onward, the workflow becomes even more visual. The complete construction can be converted into 3D at the push of a button. From the 2D+ construction, a spatial model is created that makes the planning easier to check and the geometry easier to understand. This makes checking easier and supports coordination. Designers can quickly see whether the elements are logically structured, whether the geometry fits the planning, and whether the construction works as an overall system. The 3D conversion is not a separate rebuild, but an additional workflow step. In this way, ATHENA connects several work steps in one continuous process: intelligent objects, parametric views, CAD optimization, bills of materials, evaluations, automatic dimensioning, workshop drawings, and 3D checking. The conclusion? ATHENA connects planning, adjustments, CAD optimization, bills of materials, evaluation, automatic dimensioning, and 3D conversion in a specialized working environment for metal construction and facade engineering. Repetitive tasks are reduced, changes remain more controllable, and important information can be used for downstream steps. This creates a workflow that becomes faster, more precise, and more reliable. Anyone who wants to plan Louvre and facade systems more efficiently benefits from a workflow that connects drawings, data, CAD optimization, evaluation, and 3D checking more closely. More precision, less manual rework, and a workflow that connects planning and production preparation. If you want to implement projects in metal construction and facade engineering more efficiently, get to know ATHENA. Arrange a presentation and experience what modern CAD planning looks like, without limitations.